In 1995, a 30-year-old Australian philosopher stood in front of a room of scientists in Tucson, Arizona, and asked a question so simple it broke the field of philosophy of mind in half. He did not ask how the brain works. He did not ask how memory is stored, or how attention is directed, or how the visual cortex assembles a face out of light. Those questions had answers, or at least the promise of answers. What he asked was this: why is any of it accompanied by experience? Why isn't there just a machine in the dark, processing signals, generating outputs, with nobody home? His name was David Chalmers, and he called it the hard problem of consciousness. 3 decades later, the question has not been solved. It has not been narrowed. It has not even been properly defined to everyone's satisfaction. Neuroscience has mapped the brain in resolutions Chalmers could not have imagined in 1995. We can watch a single neuron fire in a living mouse. We can decode rough images from human visual cortex using machine learning. We can predict, with uncanny accuracy, which face a person is looking at by reading their brain activity alone. And yet, somewhere in the middle of all this measured electricity, something happens that no instrument has ever detected and no equation has ever predicted. You see red, not the wavelength, not the neural correlate. The redness, the thing that is there for you and only for you when light around 700 nanometers hits the back of your eye. The universe contains stars and galaxies and gravitational waves. It contains quarks and dark matter and the cosmic microwave background. And somewhere in the middle of it, it contains the experience you are having right now, listening to this voice, watching darkness move across the screen, aware that you are aware. Physics describes the first list. It does not describe the second. We will get to why that gap might be the deepest crack in the foundation of science. But first, we have to stand at the edge of it and look down. To see why the problem is hard, you have to see what an easy problem of consciousness looks like first. Imagine you are sitting in a quiet room and someone shines a red light into your eyes. Photons strike your retina. Specialized cells called cones, tuned to long wavelengths, fire. Their signal travels down the optic nerve, hits the lateral geniculate nucleus deep in the brain, and is relayed to the primary visual cortex at the back of your head. From there, the signal spreads forward through dozens of specialized regions, each extracting some piece of the picture: edges, motion, color, object identity. Eventually, something in the brain produces the report, "I see red." Every step of that chain, in principle, is a physical process. Every step can be measured, simulated, predicted. Neuroscientists like Christoph Koch have spent decades chasing what they call the neural correlates of consciousness, the specific brain activity that lights up whenever experience occurs. They have found candidates: the posterior hot zone, recurrent processing in the cortex, synchronized firing at around 40 Hz. These are real findings, and they are deeply impressive. But notice what they describe. They describe the machinery. They describe which gears turn when. They do not in any way explain why the gears turning feels like anything at all. You could, in principle, build a machine that does everything your brain does, neuron for neuron, signal for signal, and produces the same report, "I see red," when light hits its sensors. The question Chalmers planted in 1995 was whether such a machine would have an inner life, or whether it would just be a system passing information around in the dark. This is the explanatory gap. On one side, neurons. On the other side, the redness. And between them, nothing. No bridge, no equation that takes you from the firing pattern to the felt quality. The philosopher Joseph Levine first named this gap in 1983, but Chalmers gave it teeth. He pointed out that no matter how much detail you fill in on the physical side, the question on the other side does not even begin to be answered. You can describe the neural mechanism of pain in atomic precision and still ask with a straight face why it hurts. Imagine a scientist named Mary. She has lived her entire life in a black and white room. She has studied vision in extraordinary detail. She knows every wavelength, every cone cell, every cortical pathway, every neural firing pattern that occurs when a normal human sees the color red. She has read every paper ever written on color vision. She is, in the relevant sense, the world's expert. Then one day the door of her room opens and she walks outside and she sees a red rose for the first time. Does she learn something new? The philosopher Frank Jackson posed this in 1982, and the answer most people give is yes. She learns what red looks like. That knowledge was not in any of the textbooks, no matter how complete, which means that complete physical knowledge of the brain somehow leaves something out. The thing it leaves out is the very thing we are. And nobody in 3 decades of trying has figured out how to put it back in. There is one way to make the problem disappear. You can deny that it exists. This is the position taken by the philosopher Daniel Dennett, who spent his career arguing with brilliance and force that consciousness as we naively conceive it is a kind of user illusion. Dennett, who died in 2024, was the most prominent figure in a school of thought sometimes called eliminativism, sometimes illusionism. His successor in this fight is the British philosopher Keith Frankish, who put the position bluntly. The hard problem is not hard because consciousness is mysterious. The hard problem is hard because we are mistaken about what consciousness is. There is no redness. There is no felt quality. There is only the brain representing itself to itself in a way that makes it seem as though there is something more. When you introspect, when you turn inward and notice the quality of your experience, you are not, on this view, observing some deep fact about reality. You are running a model. The model says, there is a vivid, ineffable redness here, but the model is the thing doing the saying. There is no further fact behind it. The hardness of the hard problem is an artifact of taking the model at face value. It is a clean, parsimonious view. It dissolves the explanatory gap by denying that anything needs to be explained across it. And most philosophers find it deeply, viscerally unsatisfying. The reason is simple. You can be wrong about almost anything. You can be wrong about what is in front of you. You can be wrong about what year it is. You can be wrong about whether your hand is your own. But it is very hard to see how you could be wrong about the fact that something is happening to you right now. The experience may be a model of reality, not reality itself, but the having of the experience seems to be the one thing that cannot be reduced away, because the reducing away is itself an experience. When Dennett says the redness is an illusion, you have to ask, an illusion for whom? Illusions require a subject, and the subject is the very thing being denied. So most of the field has gone in the opposite direction, not to dissolve consciousness, but to take it more seriously than ever, even at the cost of breaking some very old assumptions about what matter is. The most striking move came from a place almost no serious philosopher had gone in over a century. The view is called panpsychism, and it sounds at first like something from a 19th century occult pamphlet. It says that consciousness is not produced by complex brains. It is a fundamental feature of matter, present at every level of reality, from the electron to the human. The philosopher Galen Strawson argued for this in a 2006 paper that made other philosophers wince. He pointed out that if you start with pure physical matter, defined as having no experiential properties at all, you cannot, by combining it in any pattern, produce experience. 0 plus 0, no matter how complicated the addition, is still 0. So either experience is impossible, which we know it is not, or it was there at the bottom all along. His colleague Philip Goff has built an entire research program around this idea, not the silly version where rocks have feelings, a more austere version, where every fundamental physical entity has some minimal proto-experiential aspect, and these aspects combine in complex systems like brains to produce the rich consciousness you are having now. Around the same time, an Italian neuroscientist named Giulio Tononi was approaching the problem from a completely different angle. Tononi did not start with philosophy. He started with the brain. He developed a mathematical framework called integrated information theory, which proposes that consciousness is identical to integrated information, a quantity he labels with the Greek letter phi. Any system that integrates information in the right way has experience. The amount of experience corresponds to phi. A human brain has very high phi. A photodiode has very low phi, but on this theory, not 0. Consciousness, in Tononi's framework, is not a special trick of biology. It is a structural feature of certain kinds of information processing found in some degree almost everywhere. The implications are staggering. If Tononi is right, the cosmos is not a dark machine with a few flickers of awareness in it. It is a gradient of experience, with the lights brighter in some places and dim in others, but never quite off. The mathematician and physicist Max Tegmark has speculated along similar lines, treating consciousness as a state of matter. None of this is fringe. These are papers in peer-reviewed journals, debated by tenured professors at Oxford, NYU, the University of Wisconsin. The question is no longer whether to take consciousness seriously as a problem in fundamental science. The question is how strange the answer is allowed to get. And then it gets stranger. In the mid-1990s, around the same time Chalmers was first naming the hard problem, the British mathematical physicist Roger Penrose proposed something that nearly everyone in neuroscience initially dismissed as wild. Penrose had won the Nobel Prize in Physics for his work on black holes. He was not a crank, but he argued, in 2 long books, that consciousness could not be the product of ordinary computation. He thought there was something in the act of conscious understanding that classical physics could not capture, so he went looking for non-classical physics inside the brain. He found a collaborator in the American anesthesiologist Stuart Hameroff, who had spent his career studying what anesthesia actually does. Hameroff noticed that anesthetic gases bind to specific structures inside neurons called microtubules. Microtubules are tiny hollow protein tubes, about 25 nanometers across, that form part of the internal skeleton of every cell in your body. When anesthesia binds to them, consciousness switches off, even though the rest of the cell keeps functioning. Hameroff and Penrose proposed that microtubules are not just structural scaffolding. They are the site where quantum processes inside the brain become conscious experience. They called the theory Orchestrated Objective Reduction, OR. For nearly 30 years, mainstream physics treated this as fascinating but impossible. The brain is warm and wet and noisy. Quantum coherence, the delicate state required for genuine quantum computation, was thought to collapse almost instantly in such an environment, far too fast to play any role in thought. Then, in 2022, a team led by the physicist Jack Tuszynski and others, building on earlier work by Anirban Bandyopadhyay, published experimental results showing that microtubules can sustain quantum vibrations far longer than classical biology predicted. Other studies have observed what appear to be quantum effects in microtubule networks under specific conditions. The results are contested. The interpretation is wide open. But the simple claim that quantum coherence in the brain is impossible can no longer be made with the same confidence. Penrose's idea, which spent decades on the edge of respectability, has been pulled back toward the conversation. If OR is even partly right, then your consciousness is not just an emergent property of neurons in the usual sense. It is a process where the brain reaches down into the substrate of physics itself, the same substrate where particles do not have definite positions until they are measured, and produces an experience. The mind would not sit on top of the universe. It would be wired into its deepest layer. And now we have to ask what all of this means together, because the lines start to converge. Physics has built, over the last 4 centuries, the most successful description of reality ever achieved by any species we know of. It can predict the orbit of Mercury to within fractions of an arcsecond. It can predict the existence of particles before they are detected, the curvature of light around galaxies, the temperature of the radiation left over from the first moments of the universe, to a precision of 1 part in 100,000. The standard model of particle physics has been tested at the Large Hadron Collider in collisions of 7 trillion electron volts. The cosmological model can trace the universe from a state 13.8 billion years ago to the galaxies above your head. The instruments are exquisite. The math is brutally accurate. Reality, where we have looked, has obeyed. But none of this equipment, in any of these experiments, has ever detected what you are doing right now. The voice you are hearing is generating a pattern of vibrations in air. Those vibrations are transduced by hair cells in your inner ear into electrical signals. Those signals are processed by auditory cortex into meaningful units of sound and meaning. Every step of that is in principle describable by physics. None of it tells you why there is somebody on the receiving end, why this voice is being heard and not merely processed. The hard problem is not a gap in our maps. It is a gap in our map-making. Every variable in physics describes something objective, something that can in principle be measured from outside. Mass, charge, spin, curvature, energy. None of these variables has any place for the inside view. There is nothing in the equations of the standard model that says where the experiencer goes. The equations describe the dance. They do not describe the dancer who feels the dance from within. This is the moment Chalmers was pointing at in 1995, and which we promised we would return to. Not a small puzzle, not a temporary blank spot waiting to be filled in by a clever neuroscientist. A structural absence, a place where the most successful description of reality ever produced cannot describe the very thing producing it. Some thinkers, like the philosopher Bernardo Kastrup, take this as a sign that we have the metaphysics backwards. That consciousness is not produced by matter. That matter is what consciousness looks like from the outside. Others hold the line and insist that the gap is temporary, that some future physics will close it. But notice that no one knows what such a physics would even look like. We do not have a draft, we do not have a sketch, we have the absence of a sketch. You are the absence, the redness when you see red, the ache when you remember someone. The strange, quiet fact that there is something it is like to be you right now, listening to this voice, watching the slow stars on your screen. That is the thing physics cannot reach, and you carry it everywhere you go. The one piece of the universe that has never appeared in any equation, the one fact that every theory of everything must somehow leave out in order to be written down. There is a temptation to step back from this and say something reassuring, to wrap it in a phrase that lets you set it down before bed. The temptation should be refused, because what is being said here is not a metaphor. It is a literal fact about the situation you are in. The universe is 14 billion years old. It is 93 billion light-years across in observable diameter. It contains roughly 2 trillion galaxies. It runs on laws that have been hunted, captured, and written into equations small enough to fit on a single page. Every one of those equations describes a world without you in it. Not because you are unimportant, because the language of physics has no grammar for the first person. It can say everything except who is saying it. You are the universe at the precise point where it bends back to look at itself. That bending is real. The looking is real. The fact that there is someone here is real. And the deepest description we have ever produced of what is real has no slot in it for any of this. You are walking around inside a theory that does not contain you, and the theory works anyway, and that should be more frightening than it usually is. Maybe Dennett was right, and the inner life is some elaborate self-fiction. Maybe Goff and Strawson are right, and consciousness was always there at the bottom of things, woven into the electron, and the brain just gathers it into a richer pattern. Maybe Penrose and Hameroff are right, and somewhere in the warm geometry of your microtubules, the quantum world and the conscious world are the same world. Maybe none of them are right. Maybe the answer is a kind of theory we have not yet learned to think. Whatever it is, it will have to explain this. The voice you are hearing, the watching you are doing, the fact that behind your eyes there is a place where the cosmos is being witnessed. The hardest problem in the universe is not the origin of the Big Bang. It is not what lies inside a black hole. It is not why the constants of nature have the values they do. The hardest problem in the universe is the one that is reading these limits back, the one that, after all the equations are written, is still here. The universe can be described from the outside in extraordinary detail. It cannot so far be described from the inside at all. And the inside is where you live. The face staring back from the darkness on the screen right now is not a stranger. It is the only piece of the cosmos that has ever known it is part of a cosmos. And nothing in physics, in chemistry, in neuroscience, in 3,000 years of philosophy has yet explained how that knowing got here, or what it is, or why it happens to be you. The universe was not built for us to understand. It was built, and somehow, inside it, something woke up. You are that something. And the equation for you has not been written.